Hello guys, welcome to Sleepumentary. Tonight we are going to drift backward through almost a million years to the thinnest thread in our family story, the moment when the entire future of humanity narrowed to a handful of beating hearts. Let your shoulders drop, slow your breathing, and picture the glow of modern cities fading like embers until the map of Earth goes dark. The noise quiets, the clock unwinds, skyscrapers sink back into the plains, roads unspool into dust, satellites pinned wink out one by one. Keep drifting past the first farms, past painted caves and bone flutes, past the first sparks of controlled fire, until the world is raw and wide and almost empty of us. Tonight we are visiting a time when our ancestors could have vanished and no one would have ever known we were meant to exist. It's strange to say this as you settle under a blanket in a world of 8 billion people. But there was an era when the count of human ancestors, those capable of having children, fell to about 180 individuals, not 128 million, not even 28,000. Think of a small town's worth of people scattered across a continent separated by ridges and dry riverbeds, never suspecting that they were carrying the entire story of us. If you have ever felt that sudden chill after a near miss on the highway, that slow dawning of, we almost didn't make it, magnify that feeling to a species scale. That's the hush we're entering now. For a long time, no one knew this had happened. Scientists suspected that something in our past had squeezed our numbers because humans are oddly alike. Compared to many animals, our genetic variety is low, as if countless pages of our story were torn out and thrown to the wind. But how severe was the squeeze? How long did it last? The answers hid in our DNA like faint footprints across a storm-battered beach. Then in 2023, a team of researchers used new ways of reading those footprints, mathematical tools that let them rewind the clock on thousands of modern genomes at once. What they saw made even cautious scientists sit very still, a sharp collapse roughly 900,000 years ago, followed by an agonizingly long period about 117,000 years, when our ancestors hovered at the brink. Before we continue, if this tale keeps you company tonight, leave a like and subscribe. Only if it truly feels natural. And now softly tell me, where are you listening from? And what hour has the night brought you? Imagine waking each day in a world where survival is not assumed. The air is colder, the rain's unreliable. Ice masses in the far north tug on the planet's climate like a giant hand, and Africa, cradle of our lineage, flickers between parched and barely livable. Rivers you taught your children to follow dwindle to chains of bitter pools. The big animals thin out, the edible plants become seasonal riddles. Under a sky scoured by wind, small bands of people move with the quiet economy of necessity, 30 or 40 souls at a time, nursing children, tending aches, learning the land like scripture. Because forgetting could mean the end of a bloodline. We will spend many parts of this journey with them, but first stay with the feeling of scale. Picture a school auditorium, rows of chairs, a stage, the murmur before a play begins. Now remove almost every chair until only a few clusters remain, each group barely within shouting distance of another. That's the entire breeding population of our ancestors, for longer than all of recorded history by far. Biologists have a phrase for this danger zone, the extinction vortex. Small numbers amplify every bad roll of the dice disease storms in breeding unlucky years. Most species that get pulled into that spiral never climb out. Yet our ancestors did, for reasons we'll explore, pockets of refuge, stubborn ingenuity. Perhaps a few strokes of genetic luck. One of those strokes appears in every one of your cells. Humans have 46 chromosomes. Our close relatives like chimpanzees and gorillas have 48. Somewhere in the deep past, 2 ancestral chromosomes fused end to end, leaving a molecular seam you can still find with the right tools. In a huge population, such an oddity might vanish. In a tiny one, it can spread, especially if it doesn't harm survival. Tonight, as you breathe steadily, consider that a quiet accident in a scarce wind-battered community became a universal signature shared now by billions who build bridges and bake bread and write lullabies. The long emergency wasn't a sudden catastrophe, it was a grinding change in rhythm. Before this era, Earth's ice ages pulsed on a shorter beat. Then the cycles stretched and deepened. The cold spells longer, the dry spells harsher. Think of a drum that slows but hits harder each time. Our ancestors didn't have weather maps or orbital models, they had memory. They had stories at the fire. They had maps scratched into the mind where the spring still trickles in the bad months, which tubers need roasting to be safe, the angle of wind that means the herd shifted east last night. Knowledge became a lifeline as real as sinew ties and wooden spears. If you're listening in Berlin at breakfast or Boston at bedtime, yes, I see the comments, a chorus from every time zone. There's comfort in remembering that our ability to share information kept us alive. The voice you hear now is an echo of nights when elders taught the youngest which clouds promise rain and which promise trouble, when someone who learned a better way to carry embers between camps saved a child's fingers from frost, when the memory of a hidden spring was passed like a blessing. This instinct to teach, to synchronize our minds, is not decoration. It was selected for again and again in families who would have vanished without it. And still the numbers stayed small for a very long time. That is perhaps the most unsettling detail, how close we hovered to silence. There were likely seasons when a single bad drought could have erased entire valleys' worth of people. A broken leg could become a lineage's full stop. Yet something held perhaps a refuge where rains came reliably enough, perhaps a chain of oases, perhaps a way of managing fire that opened new foods and warded off predators. In the emptiness of the fossil record from that era, so few bones preserved, so few camp traces, there is an eerie confirmation. There weren't many of us around to leave a mark. You might be wondering if this near-death shaped not only our bodies but our minds. That's a question the scientists now ask with new seriousness. In tiny scattered groups, raw strength helps, but cooperation helps more. Memory helps, patience helps. The baby who watches carefully, the child who learns quickly, the adult who can see another's intention and de-escalate a conflict, these are survival traits in a world where every individual matters. Over thousands of generations, such traits ripple forward. And so here we are, a species disproportionately good at teamwork, at tool-making, at long-term planning, at telling stories that transmit what works. Let your breathing lengthen again. We have a long way to go, but tonight's first step is simple: hold two images at once. First, the modern planet airplanes carving lines over oceans, city lights, like constellations fallen to Earth, messages crossing continents in the blink of an eye. Second, a sparse landscape under unfamiliar stars, a few dozen people curled near embers sharing the day's findings in low voices, while jackals bark far off. Those two worlds are connected by a rope stretched across nearly 1 million years, spliced and frayed, and yet unbroken, because at some unthinkably fragile moment our ancestors refused to let go. Before we drift deeper, do the small ritual that ties this community together. Dim the screen if you can. Breathe in for 4, out for 6. If you want, tell me where you are and what time it is: Tokyo at midnight, Nairobi just before dawn, Sao Paulo in the gentle after rain. I read them. It reminds me that a species which once survived by whispering knowledge across a fire now whispers across oceans, still trying to keep one another alive and calm. Tonight we begin with the brink. The discovery that our lineage pressed so close to nothingness that you could count the survivors on your fingers and toes many times, but not that many. In the next part, we'll step into the lab where modern tools peeled back the curtain on this secret, how patterns in our DNA, like faint rings in ancient wood, revealed the collapse, and how cautious minds, skeptical at first, became convinced. For now, rest with the paradox: we are fragile and we are enduring. The story could have ended in silence. Instead, it became a lullaby, carried forward by 1,000 and a few. The story of how we even know about this bottleneck begins not in a cave or a dusty fossil bed, but in the bright white light of a laboratory at the Chinese Academy of Sciences. Picture a man named Wang Ji, bent over rows of humming computers and endless columns of genetic data. He wasn't hunting for a mystery of extinction. He was doing what population geneticists often do, analysing the DNA of thousands of modern humans, building timelines of mutations that tick backward like the steady beat of a molecular clock. Each mutation is a breadcrumb, a faint trace of where our lineage walked through time. For years, the tools available to scientists were like squinting at a forest through a keyhole. They could see fragments of history. Yes, humans had been through some kind of reduction in population size, but the outlines were fuzzy and incomplete. The genome whispered that something had happened, but not when and not how severe. Wang Ji and his colleagues wanted sharper vision, so they used a new computational method, one of those beautiful marriages between mathematics and biology. It was called FIT-COAL, short for Fast Infinitesimal Time Coalescent. It allowed them to take DNA samples from more than 3,000 people across the globe and run models that could rewind genetic drift nearly 1 million years into the past. At first, the data seemed like a glitch. Around 900,000 years ago, the lines of genetic diversity didn't just narrow, they collapsed, plunging downward as though most of humanity's ancestors had suddenly walked off stage in the middle of the play. What should have been a broad tree of branching variation shrank into a thin stalk. The numbers were brutal. Roughly 98.7% of all breeding individuals gone, fewer than 1/300 left alive to carry the torch. Wang Ji stared at the models and refused to believe them. Any scientist knows that extraordinary claims require extraordinary evidence, and this result was almost absurd. A species can survive bad harvests, volcanic winters, diseases. But to be whittled down to numbers smaller than a suburban high school student body, that was the kind of thing that ends a lineage, not preserves it. So he did what good scientists do, he doubted himself. He reran the simulations, he tweaked the inputs, adjusted the assumptions, asked colleagues to check his work. Again and again, the lines traced the same terrifying valley in the genetic record. The more carefully he checked, the more relentless the signal became. This wasn't noise, this was history. Imagine the feeling of realizing you've uncovered something no human has ever known. The room looks the same, the world outside unchanged, but in front of you is evidence that our species, every living human, every ancestor once balanced on a razor-edge of non-existence. That for over 100,000 years the human story could have ended in a quiet, forgotten way, with only the bones of other animals left in the strata. Colleagues across the world would later echo his disbelief. Some compared it to discovering that humanity had been reduced to the size of a single village for longer than recorded history itself. It was not a quick disaster like a plague sweeping through in a season. It was a drawn-out narrowing and extended bottleneck that persisted through countless generations. As you breathe slowly now, consider the patience behind that discovery. Each chromosome, each segment of DNA from thousands of donors had to be aligned, compared, tested, run through mathematical models again and again until the patterns became undeniable. The genome is a stubborn storyteller, reluctant to give up its secrets. But when it does, the tale is chilling. And so in 2023, Wang Ji and his team published the results in the journal Science. The world of anthropology and genetics rippled with shock. They hadn't just uncovered a minor blip in our past. They had revealed an existential crisis that lasted longer than our species has even existed. From that moment, the quiet hum of lab equipment took on the weight of prophecy. Every child laughing in a park, every city lit against the night, every song and every language, all of it flowed from fewer than 1/300 survivors. In the next part, we'll sit with the weight of that number. We'll explore why populations that small usually don't recover, why biology itself seems stacked against them, and how our ancestors managed to resist the extinction vortex that pulled so many species down. For now, let the thought settle one discovery, one stubborn pattern in DNA peeled back the curtain on the narrowest passage in our story, and suddenly all of human history tilted into focus. The numbers sound almost unreal, and maybe that's why they keep echoing through your head, 98.7% gone. Imagine you're looking at a crowd of 100 early humans, men, women, children. Then you blink and only one or two are left standing. That's what the genetic data shows. From an entire flourishing population down to roughly 180 breeding individuals scattered across Africa in fragile groups. To put it in modern terms, picture a single high school, one of the small ones, maybe just a few grades, 1,000 or so students and teachers. Now imagine that this one building, this little community, is all that remains of humanity. No sprawling cities, no distant relatives across continents. Just that one school's worth of people divided into tiny bands, each one moving through harsh landscapes, never knowing that the fate of the species rested on their survival. That's the razor's edge our ancestors lived on for more than 100,000 years. Biologists have a grim phrase for what happens when populations shrink this far, the extinction vortex. Once you spiral into it, the odds of climbing out are slim. Numbers this low mean inbreeding is inevitable. Cousins pairing with cousins, children born with higher risks of genetic disorders, weaker immune systems, reduced fertility. Every birth carried extra risk, and every death was a devastating blow to the group's future. Imagine losing one skilled hunter, one elder who knew where water could be found. One mother with infants still nursing losses like that could tilt an entire band toward collapse. Small populations also suffer from bad luck in ways large ones can withstand. A lightning storm, a disease sweeping through even a year of failed rains could wipe out an entire clan. With so few humans left, there was no safety net, no distant relatives to replenish the numbers. A single unlucky event could have meant the end of us, and yet somehow it didn't. Most species that fall this low never rebound. They vanish from the fossil record and become nothing more than footnotes in evolutionary history. The extinction vortex pulls them down generation by generation until they are gone. Think of the countless animals that once roamed Earth. Giant ground sloths, saber-toothed cats, whole families of antelope and elephant-like creatures. They were once abundant, then reduced, then erased. Their absence is the rule. Our survival is the exception. Even today, conservationists know how dangerous this threshold is. When the population of a rare animal falls below 1,000 alarm bells ring. Biologists rush to protect habitats to manage breeding to try to keep the species from sliding past the point of no return. And yet 900,000 years ago, our ancestors didn't have wildlife reserves or genetic banks. They had only themselves, stone tools, fire when they could keep it alive, knowledge whispered in the dark, and the stubborn will to continue. So as you breathe slowly, think of the fragility of that moment. Entire continents empty of human voices, save for a few tiny gatherings huddled near waterholes or clinging to valleys that still held food. The nights were long, the stars unchanging, and the silence immense. The odds said we shouldn't be here, that this story should have ended before it began, but it didn't. In the next part, we'll stretch out the timescale and see just how long this knife-edge balance endured, not a decade, not even a few centuries, but more than 100 millennia of precarious existence. That span of time reshaped what it meant to be human. It's tempting to imagine a catastrophe as a single event, a volcanic blast, or a sudden plague, a collision with an asteroid. Something dramatic over in a season or two. But the truth revealed in our DNA is far stranger and far more unsettling. Our brush with extinction wasn't a single sharp wound. It was a slow, unrelenting squeeze that lasted not decades, not centuries, but 117,000 years. Pause for a moment and let that number sink in. Modern Homo sapiens. Our species has only existed for about 300,000 years. The entire record of recorded history, writing cities, nations, everything? So you know. A civilization spans maybe 5,000 years. Against that scale, 117,000 years is staggering. It is half as long as we in our present form have existed at all. For thousands upon thousands of generations, our ancestors lived on a razor's edge, never certain that there would be enough food, enough children, enough luck to keep the story moving forward. Picture it in terms of family lines. A single human generation averages about 25 years. Multiply that and you're looking at more than 400-600 generations living and dying inside this bottleneck. Each generation small, each one vulnerable. When one band lost members to drought or disease, there was no guarantee another group would be nearby to help, and yet somehow against the current of probability, the line continued unbroken. This was not survival in the way we like to think of it. Progressive, inventive, steadily moving towards civilization. There was no triumph here, no gradual climb toward greatness. There was only endurance. For over 100,000 years, life was pared down to its core tasks. Find water, find food, keep fire alive, keep children alive. Every successful birth was a victory. Every avoided conflict, every passed-on skill, every shared mouthful of food tilted the balance away from extinction. And the suspense of it lingers even now. How? How did they not vanish like so many other species had before them? How did a group so small and so fragile resist the extinction vortex that claims nearly all others? Was there a hidden refuge, a pocket of land where rains came steady, where plants still grew, where prey animals still lingered? Did they discover some secret, some crucial innovation, like fire mastery or new food sources that gave them just enough of an edge? Scientists debate the answers, but the fact remains was survival stretched on for a span of time almost beyond comprehension. It was as if humanity was trapped in a corridor with the walls pressing inward, the ceiling lowering the floor, cracking beneath, and yet somehow slowly, step by step, they walked through, without being crushed. When you look up at the stars tonight, remember that during those 117,000 years, our ancestors saw those very same constellations. Night after night, under skies unsullied by city lights, they must have stared upward, wondering if tomorrow would bring rain or food or death. And somehow, through 400-600 generations of uncertainty, they endured long enough for us to exist at all. In the next part, we'll explore what was happening in the world itself during this long ordeal. The violent climate shifts that transformed landscapes, dried rivers, and turned survivable environments into traps. To understand our survival, we first have to understand the storm we walked through. If you want to understand why our ancestors dwindled to fewer than 1,300 souls, you have to step back and look at the world itself. Earth 900,000 years ago was a planet convulsing through one of its great climate transitions. Geologists call it the early Middle Pleistocene transition. To our ancestors, it must have felt like the world itself was breaking its promises. For millions of years before this shift, the rhythm of Earth's ice ages had been steady and predictable. Every 41,000 years or so, glaciers waxed and waned. Cold periods would come, but they were manageable. Ice sheets advanced across parts of the north, then retreated, letting ecosystems rebound. It was a harsh drumbeat, but one that life had adapted to. Then something changed. The drumbeat slowed, but grew heavier, like thunder rolling in longer, more punishing waves. The cycles of ice and warmth stretched to 100,000 years, each cold phase longer, deeper and more catastrophic than before. Vast ice sheets blanketed North America, northern Europe and Siberia. Sea levels dropped by hundreds of feet, exposing raw seafloors and land bridges. Ocean currents shifted, pulling heat away from the tropics. And Africa, the cradle of our lineage, was reshaped most brutally of all. With so much water locked away in ice, rainfall patterns faltered. The reliable monsoons that had once fed rivers and wetlands grew erratic. Woodlands thinned into grasslands. Grasslands became scrub. Scrub became desert. What had once been lush savannas filled with animals turned into dust and stone. Imagine standing where your grandparents had hunted gazelle in shaded groves only to find sand dunes and empty silence. It wasn't just inconvenience, it was ecological collapse. Herd animals that had sustained human bands starved or vanished. Plant foods dried out of the soil. Water sources shrank to muddy trickles fought over by every thirsty creature. To early humans, possibly Homo erectus, or Homo heidelbergensis, ancestors of both US and the Neanderthals, the world was no longer predictable. It was treacherous. This was in every sense a perfect storm for extinction. Cold northern climates strangled ecosystems while Africa burned and withered. Large animals died out in waves, taking with them the predators and scavengers that had relied on them. And with fewer than 1,300 humans left, there was no room for mistakes. A drought that lasted a few seasons could kill half a band. A failed migration could scatter survivors into oblivion. A single disease could erase a valley's worth of people. Yet in the teeth of this storm our ancestors endured. Somehow, somewhere, a few small groups found refuge as pockets of relative stability, places where food and water held out just enough. Places where the fire of humanity, which should have gone out, guttered but refused to die. As you breathe, imagine the weight of that sky glaciers glittering at the edges of continents' deserts spreading across Africa, seas shrinking away from their coasts. A world both frozen and burning hostile from pole to equator. A world that pressed almost every other lineage toward extinction and very nearly did the same to us. In the next part we'll zoom in from the planetary scale to the human one stepping into the skin of an early ancestor trying to survive amid vanishing rivers and dwindling prey. What did daily life look like on the edge of annihilation? Close your eyes and imagine the world as it was 900,000 years ago. You are not standing in a bustling city, nor even in a farming village. You are part of a small weary band of perhaps 30 people, your family, your kin, maybe a few distant cousins. The land around you is not the lush woodland your grandparents spoke of. Where there were once thick trees buzzing with insects and alive with birdsong, there are only stretches of scrub-dry grasses rattling like brittle bones in the wind. The rivers your parents followed to water and game now trickle weakly, sometimes disappearing into cracked earth altogether. The silence is unnerving. Animals that once thundered across the plains are gone. The great herds of antelope and elephant have collapsed. You might see a zebra once in a season, thin and wary, not enough meat to feed everyone for more than a few days. The old trails where hunters once tracked abundance now lead only to dust. You move constantly, feet sore, stomach hollow, carrying little more than stone tool skins and the fire you've managed to keep smouldering in a bundle of bark and ash. Fire isn't just warmth. It's life itself. Without it, food is harder to eat, nights are colder, predators draw nearer. You sleep in small circles, backs pressed together, children tucked inside listening to the wind scrape across empty land. Sometimes you hear jackals or hyenas in the distance, their calls unnervingly close. But mostly you hear nothing. No frogs in the wetlands, no birds gathering at dawn. silence where there should be life. That silence is a weight you carry as heavily as the infants on your shoulders. Water rules everything. Each morning begins with the same desperate question: where will we drink today? You scan the horizon for green smudges, perhaps a patch of trees that hints at a spring, perhaps the glint of water pooled in a hollow. You dig in the mud with sticks, sometimes finding a few mouthfuls of brackish water, sometimes nothing. When you do find a stream, the group drinks greedily, but never too much, because predators come to water as well, and thirst can drive desperate fights you cannot afford. Food is a scattershot hope. Roots pulled from the hard ground, bitter, but edible when roasted. A clutch of bird eggs stolen at dawn. Termites cracked open from their mounds, tiny bodies rich in fat and protein. The luck of stumbling across carrion, a zebra already dead, a deer weakened by thirst. Each discovery is shared, parcelled out carefully, because if one child starves, the whole group suffers. Every life matters. There are no extras to lose. At night, the elders remember a different world. They tell stories of forests that once sheltered them, of animals that were once plentiful. But the children listening have never seen such things. To them, the desert, the scrub, the endless wind, this is all the world has ever been. They don't know they are clinging to survival in the middle of a long, grinding disaster. They don't know their lives are the thin thread upon which the future of humankind hangs. And yet amid the hardship there are small victories. A spring that still flows even after months without rain. A band of gazelle caught in a rocky gorge yielding precious meat. A fire kept alive through a stormy night. These moments are celebrated not with laughter, but with quiet relief, with the knowledge that they will see another sunrise. Try to feel what that existence was like. No guarantee of tomorrow, no certainty of safety. No abundance to rely on. Every dawn began with fear, every night ended with exhaustion. And still they endured, still they walked forward into the dry winds and empty plains. In the next part we'll explore how some of these groups may have found hidden refuges, geographical sanctuaries where rain still fell or rivers still flowed, pockets of survival that allowed humanity's flame to continue flickering against the darkness. How did they do it? That is the riddle at the heart of this long survival. If nearly all early humans perished, why did a small group, barely more than 1,000 breeding individuals, manage to hold on while others vanished into silence? The answer isn't written in fossils, because there are almost none from this period. It isn't obvious in stone tools, because the record is sparse. What we have instead are fragments of climate data, genetic models, and educated speculation. Scientists chase this puzzle like detectives hunting for a crime scene long since washed away by rain. One leading idea is that survival was tied to water, always water. In times when much of Africa grew arid and barren, a few places continued to offer reliable sources. The Great Lakes of East Africa. Victoria, Tanganyika, Malawi are often suggested as possible refuges. Fed by deep basins and complex rainfall patterns, they may have remained habitable when surrounding regions withered. Imagine small bands of humans clustered along lake shores, fishing with sharpened sticks, gathering roots from damp soils, keeping fire alive on beaches, while watching hippos and crocodiles claim the same precious resource. Others point to the rift valleys of East Africa, dramatic fractures in the Earth's crust that create unique microclimates. Valleys can trap moisture, funnel rainfall, and preserve patches of woodland even when nearby plateaus are dry. A rift valley with a steady spring might have served as a cradle of continuity, shielding tiny groups from the worst droughts. Still others propose the existence of underground aquifers, hidden reservoirs that kept certain springs and oases flowing year after year. To a thirsty band, the knowledge of one dependable spring, passed down like sacred lore, could have been the difference between extinction and endurance. Picture an elder leading children along a barren ridge, then stopping at an unremarkable hollow. They dig patiently until dampness seeps through the sand. A trickle becomes a pool. Life goes on. There's also the possibility of coastal refuges. During periods of falling sea levels, shorelines expanded, revealing tidal flats rich with shellfish. Bands that knew how to gather mussels, crabs, and seaweed might have had a more stable food supply than those chasing dwindling herds inland. Evidence from later periods shows that coastal diets often buffered humans against climate instability. Perhaps the same was true here 500,000 years earlier. What's striking is that scientists don't all agree on the exact location of these refuges. Some argue for a small cluster of regions in East Africa. Others suggest multiple refuges scattered more widely, each sustaining a handful of survivors who are loosely connected. What the genetic data confirms, however, is that all of us, every human alive today, descend from those scattered few. Whether their refuge was a rift valley, a lakeshore, a spring-fed oasis, or some combination, it was enough to keep the thread unbroken. And imagine the weight of memory in those places. For generation after generation, the knowledge of the spring that never fails or the lake that always has fish would have been more valuable than any tool. Survival wasn't just about geography, it was about teaching, remembering, and passing down. Children who forgot the trail to water would never grow old enough to teach their own. So the mystery of the refuge endures. We may never know the exact valley, the exact shoreline, the exact hidden spring. But we know it existed because we are here. And in some forgotten corner of Africa, 900,000 years ago, a few hundred humans found the one thing most of their kin could not, a place to wait out the storm. In the next part, we'll turn from geography to genetics, exploring how in the crucible of such small numbers a rare accident occurred, the fusion of 2 chromosomes into one, a change so unusual it would reshape the destiny of our species. Somewhere in the haze of that long survival, as bands of weary humans clustered near springs and lakes, something astonishing happened. Not in the sky, not in the earth, but deep inside a single cell. 2 chromosomes, separate pieces of DNA that had travelled faithfully through generations, fused together end to end. Instead of 48 chromosomes like our ape relatives, chimpanzees, gorillas and orangutans, we now carried 46. That moment of fusion created what we now call chromosome 2, and it remains one of the clearest genetic fingerprints that separate humans from every other primate alive today. Think of it as a seam in a fabric where 2 panels have been stitched together. Scientists can actually see the molecular scars. On chromosome 2, there are remnants of what were once 2 separate end caps called telomeres, fused together in the middle of a single chromosome. Nearby, they can also detect traces of what used to be 2 centromeres, the anchor points that help chromosomes divide during cell replication. One of those centromeres is now silent, a fossilized reminder of the day 2 ancestral chromosomes became one. It is forensic evidence as clear as a fingerprint at a crime scene, proof of a moment when chance altered the blueprint of an entire species. What makes this extraordinary isn't just that the fusion happened, it's that it spread to every human alive today. Chromosome fusions are exceedingly rare events, and in large populations they almost never take hold. One individual might carry it, might even pass it to a child or two, but in a sea of tens of thousands the mutation usually vanishes. The odds are stacked against it becoming universal. But during the bottleneck, the rules were different. When the world's human population was only around 180 breeding individuals, even the quirks of a single person could ripple outward. If one ancestor with the fused chromosome had children, and those children survived, their descendants might soon represent a significant fraction of the entire population. Within a handful of generations, what began as a genetic accident could become a shared feature of nearly everyone. Small numbers magnify chance. In a vast city, one person with blue eyes is barely noticed. In a village of 30, that feature can define a lineage. So in the crucible of near extinction, chromosome 2 became a permanent part of our story. Today, every one of the 8 billion people on Earth carries it. Whether you're in Nairobi or New York, Sao Paulo or Seoul, your cells bear the legacy of that fusion. It is a genetic signature that whispers of the time when humanity's flame burned low and an accident of DNA spread, not because it made us stronger immediately, but because the population was small enough for fate to take the wheel. And yet some scientists believe it wasn't just neutral fate. Genes located near the fusion site influence neural development. It's possible, though, still debated, that this fusion nudged our brains along a new path, setting the stage for greater complexity in thought and behaviour. If so, then the most important tool we've ever had our minds may trace its origins to this quiet chromosomal stitch made in a world that was falling apart. In the next part, we'll follow this thread further, exploring what the fusion might have meant for human intelligence and how a species on the brink of vanishing may have been reshaped by this rare genetic twist. If chromosome fusion was nothing more than a quirk of fate, it would still be astonishing an accident frozen in the DNA of every person alive, but scientists wonder if it was more than that. What if this fusion wasn't just a stitch in our genome, but a pivot point in human evolution? What if in the middle of near extinction, a genetic accident helped unlock the very thing that makes us human? Our minds. Chromosome 2 is not a silent passenger. Genes near the fusion site are linked to neural development, influencing how brain cells grow and communicate. Some affect the wiring of synapses, the microscopic connections that allow thoughts to spark across neurons. Others play roles in how the cortex, the brain's outer layer, organizes itself. These aren't minor details. The cortex is the seat of language, reasoning, imagination. Without it, there would be no cave art, no mathematics, no whispered lullabies. So the theory is simple and breathtaking. When two ancestral chromosomes fused, they may have reshaped the regulation of these neural genes. Not in a way that instantly created poetry or firelight stories, but in subtle shifts that gave our ancestors a slight edge, more flexible problem-solving, sharper memory, a keener ability to cooperate. In a large population, such an advantage might have been diluted, lost in the statistical shuffle. But in a tiny population struggling for survival, even a small improvement could mean the difference between life and death. Think of it as a spark falling into tinder. In most forests it goes out unnoticed. But in a dry, fragile wilderness, that spark can grow into a flame that spreads everywhere. The fusion of chromosome 2 may have been that spark, a random accident that in the right conditions transformed into the foundation of human intelligence. Of course, not every scientist agrees. Some argue the fusion was neutral, a passenger with no real effect. Others suspect it created vulnerabilities, side effects we still live with today. And yet the timing is uncanny. The fusion appears during the very bottleneck when humans were under the most intense evolutionary pressure in our history. It is hard not to see connection in that coincidence. Imagine it, fewer than 1/300 individuals alive, huddled around fragile fires, watching their children's eyes for signs of understanding. Among them, descendants of the one who carried this fused chromosome. Perhaps those children learned just a little faster, remembered just a little more. Perhaps they could coordinate a hunt more clearly, or imitate tool-making more precisely. Those slight advantages would ripple outward generation by generation until all carried the same fused chromosome, until every human brain carried the faint fingerprints of that accident. And today, every time you solve a puzzle, every time you teach a child, every time you picture something that doesn't exist and then bring it into being, you are living proof of the accident that might have changed everything. The entire arc of human culture, cathedrals, spacecraft, sonnets and symphonies may trace back to a seam in our DNA, where two chromosomes once collided and became one. In the next part, we'll step back and look at how scientists first uncovered this long-hidden history, how the genetic evidence was read, why older methods missed it, and how a new generation of tools finally revealed the bottleneck in full. If you enjoyed this moment, leave a comment with the number 1 below, so I know you're still here with me. Our DNA is more than just a blueprint for building bodies, it is also a time capsule. Each tiny mutation, each duplication or deletion is like a notch carved into a tree trunk. Over generations, these marks accumulate, preserving a record of what our ancestors endured, but like any archive, it takes the right tools to read it properly. For decades, scientists knew something was odd about human genetics. Compared to other primates, our diversity is strangely low. Chimpanzees scattered across Africa, living in small isolated groups, have far more genetic variation than all 8 billion humans combined. That imbalance whispered of a past crisis, a bottleneck that erased much of our variety. But the signal was fuzzy. Traditional methods of population genetics, powerful though they were, could only peer so far into the past. It was like trying to watch a movie through a keyhole. You caught glimpses of characters, but never the whole story. Earlier analyses detected that humans had endured population squeezes before, especially around 60,000 years ago when modern humans left Africa. But those methods blurred anything deeper in time. The ancient scars of the 900,000-year bottleneck remained hidden in the noise. That changed with the advent of Fickle, short for fast infinitesimal time coalescent. Think of it as a way of rewinding genetic drift with exquisite precision, reconstructing population sizes from the patterns of mutations scattered across thousands of genomes. Instead of reading a handful of data points, Fitkol could track billions of genetic markers at once, running models that stretch back nearly 1 million years. When Wang Ji and his team applied it to DNA from more than 3,000 people worldwide, the results stunned them. Around 930,000 years ago, the lines of genetic diversity plunged like a cliff. The model screamed of collapse, nearly nutuant, of breeding individuals gone. Not a dip, not a wobble, but a canyon that stayed deep for 117,000 years. At first, the team hesitated to believe it. Was the program miscalibrated? Were the assumptions flawed? They checked, recalibrated, reran the models again and again, but the signal wouldn't go away. It was written too clearly in the genome. Every living human carried the scars, the fingerprints of survival through near annihilation. When they finally published the results in 2023 in the journal Science, the reaction was immediate. Headlines around the world announced that humanity had once been reduced to fewer people than fit in a single village. Anthropologists, archaeologists, and geneticists debated furiously. Some called it the most important discovery in human evolutionary genetics in decades. Others urged caution, reminding us how extraordinary the claim was. But no one could ignore it. The genome had spoken. The discovery reframed everything we thought we knew about human history. The idea that we nearly vanished, clinging to existence for longer than civilization has lasted, was no longer speculation. It was a measurable fact preserved in the double helix of every cell in your body. And this raises the deeper question: if most bottlenecks in evolutionary history are short and sharp, why was ours so long, so brutal, and yet somehow survivable? In the next part, we'll explore why our near extinction was unlike almost any other, and what kind of extraordinary stability a tiny population would have needed to endure across more than 100,000 years. In evolutionary history, population bottlenecks are not unusual. Species have been squeezed by disasters many times: volcanoes erupting, diseases sweeping through sudden droughts, emptying whole landscapes. But those events tend to leave brief scars. A volcanic winter might kill off most of a species in a few years, yet survivors bounce back within a handful of generations. A plague might take 9 out of 10, but once it passes, the population rebounds. The signature is sharp then shallow. The human bottleneck 900,000 years ago was different. It wasn't sharp, it wasn't shallow, it lasted an almost unimaginable 117,000 years. That's not a wound, that's a chronic condition stretching across thousands of generations. Imagine a candle burning not in a gust of wind, but in a steady storm, the flame never snuffed out but never allowed to grow. That was humanity for more than 100 millennia. Archaeologist Nick Ashton of the British Museum put it plainly: after reviewing the 2023 findings, for such a small group to endure so long, there must have been extraordinary cohesion. A community of fewer than 1/300 breeding individuals would need to hold together with remarkable stability. Resources had to be just sufficient social ties strong enough and stresses low enough to prevent collapse. In his words, survival at that scale implies a localized area with good social cohesion. Think about what that means. In a tiny band, every quarrel mattered. Every lost life cut deeply into the group's ability to persist. Cohesion wasn't optional, it was life itself. These ancestors would have needed to share knowledge freely to cooperate, even when hunger gnawed to care for the sick instead of abandoning them. Fragmentation, violence, or selfishness could have doomed them. Cohesion, patience, and memory held them together. And then there's the matter of stability. If you've ever balanced a glass of water on your palm while walking, you know how small movements can spill everything. For our ancestors, the glass was survival itself. For 117,000 years, they managed not to spill it. Perhaps they found valleys where rainfall never completely failed, or river systems fed by groundwater that never dried up. Perhaps they learned strategies to buffer themselves against scarcity fire, for cooking clever ways to stretch food cooperative childcare to reduce infant mortality. Whatever the precise reasons, this bottleneck stands alone in evolutionary history. Most species that collapse so dramatically vanish forever. Those that survive usually rebound quickly once conditions improve. But humans lingered at the edge for an age longer than our species has even existed. Somehow, impossibly, we endured. As you breathe in and out, let that thought settle. We are here, not because our ancestors flourished, but because they endured at levels of fragility no species should have survived. The sheer length of that survival makes it almost miraculous. In the next part, we'll shift from survival itself to the archaeological mystery it left behind, the long stretch in which human fossils all but disappear, creating a silence in the record that puzzled scientists for decades. For decades, archaeologists stared at a void in the record and scratched their heads. Between roughly 950,000 and 650,000 years ago, human fossils seemed to all but vanish. Before this span, there were scattered remains of Homo erectus in Africa and Eurasia, traces of thriving populations. Afterward, the fossil trail picked up again, leading toward the ancestors of Neanderthals, Denisovans, and modern humans. But in that middle stretch, 300,000 years, there was almost nothing. Scholars called it the fossil gap, and it was one of the great puzzles of paleoanthropology. For a long time, explanations varied. Perhaps sediments from this period were poorly preserved. Perhaps erosion erased the evidence. Perhaps researchers simply hadn't been digging in the right places. But year after year, excavation after excavation, the silence remained. It was as if our ancestors had thinned into mist. Now we know the truth, there were simply too few of them. When a species numbers in the millions, the odds are good that at least some bones will end up fossilized under the right conditions, buried in mud, caught in caves, entombed in ash. But when you have fewer than 1/300 breeding individuals scattered across an entire continent, the odds collapse. The chances of one person's remains being preserved undisturbed, fossilized, and later found by modern scientists are infinitesimal. The fossil record didn't fail us. It reflected reality. Our ancestors were almost invisible because, for all practical purposes, they almost were. Imagine trying to piece together the story of a city if only one or two scraps of pottery survived. That was the task of archaeologists confronted with this gap. For years, it seemed inexplicable. Now, with genetic evidence, the silence speaks clearly. The population was so small, so scattered, that they left almost no trace behind. And this realization changes how we view those few fossils we do have from the period. A jawbone in Europe, a fragment in Asia, these might not represent the main line of our ancestry at all. They could belong to side branches, groups that skirted extinction for a while but ultimately died out. The true survivors, the ones who would give rise to every human alive today, may have been huddled in Africa, leaving behind nothing but the faintest genetic echoes. It is haunting to think that for more than 100,000 years, our ancestors walked hunted, gave birth, and died, and yet almost no physical trace of their existence remains. The earth swallowed them without a whisper. The only reason we know they were there at all is because their descendants survived long enough to pass their DNA to us. So the fossil gap is no longer a mystery of geology. It is the testimony of fragility. The long silence in stone is the shadow of our near extinction, written not in bones but in absence. In the next part, we'll consider how survival might not have been uniform across regions, how some groups outside Africa may have fared differently, and why genetic evidence shows that in the end every surviving lineage funneled back to the same tiny population. When we look at the fragmentary evidence from this distant age, it's tempting to wonder if the story was more complicated than a single refuge in Africa. After all, a few fossils from Europe and Asia fall within the bottleneck window. Could it be that small groups of early humans endured there too, living parallel struggles under different skies? It's possible. Eurasia is vast, and some populations of Homo erectus were already established there before the Great Climate Shift. In regions less devastated by drought, say in sheltered valleys or along temperate coasts, tiny enclaves might have survived a while longer. Maybe they clung to riverbanks in southern Europe or to forest edges in what is now China. These groups may even have left behind the few bones we puzzle over today. But here is the striking truth revealed by genetics. No matter where such outposts existed, their lineages did not continue. The DNA of every living human, and even of the Neanderthals and Denisovans, traces back to the same narrow route, the same 1/280 survivors. Whatever parallel populations may have flickered in Eurasia, their branches were pruned. Their genetic legacy vanished, leaving behind only fossils, not descendants. Africa, by contrast, was enormous and ecologically diverse. Even under crushing aridification, it likely offered multiple localized refuges, pockets where rainfall lingered, where aquifers kept springs alive, where lakes remained habitable. Imagine a continent fractured into ecological islands, one valley with a steady stream, another with reliable tubers, a coastal stretch with shellfish beds. Different groups may have been separated by hundreds of miles, living in almost total isolation, but each group carried the same desperate thread of survival. Over time, as climates shifted, these small enclaves may have merged, mingled and traded genes. What mattered is that together across scattered refuges, the total number of breeding individuals hovered at that terrifyingly low figure. Enough to keep humanity from vanishing, but only just. And from those survivors came all the rest. The Neanderthals, who would later thrive in Ice Age Europe. The Denisovans, whose taproot spread through Asia and left traces of their DNA in Tibet and the Pacific. And of course us Homo sapiens emerging from Africa much later to circle the globe. So while regional populations may have fled here and there, the genetic record shows a single truth. Everyone alive today is family descended from the same fragile root. The diversity we see in skin, in hair, in language and culture, all of it is variation built upon the foundation of those 1,000 and a few who've endured when the world nearly erased us. In the next part, we'll examine what was lost in that narrowing, how a catastrophic reduction in numbers stripped away most of our genetic diversity, leaving us more uniform than we should be, and more vulnerable in ways we still carry today. The numbers are stark. Geneticists estimate that during the Great Bottleneck, humanity lost about 65% of its total genetic variation. To grasp how staggering that is, compare it to the more familiar Out of Africa event 60,000 years ago, when a small band of Homo sapiens left the continent and spread across the world. That episode, which shaped much of our global ancestry, reduced variation by only about 15%. The earlier crisis was 4 times more severe. What does it mean to lose that much genetic diversity? Imagine humanity as a library filled with books. Each gene variant is a story, a potential defense against future challenges. After the bottleneck, 2/3 of those stories were torn out and burned. The shelves looked full enough for survival, but vast chapters of possibility were gone forever. One consequence is our immune system. Compared to other primates, humans are unusually vulnerable to infectious diseases. Chimpanzees, even when separated into small groups across Africa, maintain more genetic variation in their immune defenses than the entire human species does today. When a virus sweeps through us, it often finds similar weaknesses in millions of people at once. That lack of variation is a scar of the bottleneck, an ancient wound that still shapes every flu season, every epidemic. Another consequence is the persistence of genetic disorders. In a larger, more varied population, harmful mutations often vanish. They are diluted by sheer numbers. But in a population of only 280 breeders, quirks of DNA can become fixed, spreading through the whole species. That is likely why certain inherited conditions remain surprisingly common among humans, even when they reduce survival chances. In a cruel twist, what should have been eliminated was instead locked into our genome by the narrowness of survival. There's also the matter of fertility and adaptability. Reduced variation means fewer combinations for evolution to draw upon. When climates shift or when diseases emerge, a species with deep genetic variety has a wider toolkit to adapt. Humanity, having lost most of its toolkit 900,000 years ago, has always carried an element of fragility beneath the surface of our apparent dominance. And yet here's the paradox: these scars are also proof of triumph. Every weakness in our DNA is evidence that our ancestors survived long enough to pass it on. Our vulnerabilities to disease, our susceptibility to certain disorders, these are the fingerprints of those 1,000 and a few who managed to endure. They lived, they reproduced, and so their flaws alongside their strengths became ours. Think of it as carrying both shadows and light inside our genes. The shadows remind us that survival was never guaranteed, that we are still paying the price of the narrowing. But the light reminds us that the narrowing did not break us. From a genetic library reduced almost to ash, humanity rebuilt itself into a sprawling global species. In the next part, we'll look at how after tens of thousands of years of clinging to the edge, something shifted. Populations began to grow again, fire spread more widely, tools became more sophisticated, and the long night of scarcity finally started to lift. For over 100,000 years, humanity's story was a whisper. Small groups huddled in scattered refuges, each generation wondering if it might be the last. But then something changed. Around 13,000 years ago, the long stagnation began to lift. The bottleneck that had pressed so tightly on our lineage slowly loosened its grip, and for the first time in over 100 millennia, human populations began to grow. The recovery seems almost abrupt when viewed on the scale of deep time. For 17,000 years, the numbers stayed perilously low. Then within a few thousand years, a blink in geological terms, our ancestors multiplied. The question is why? What new advantage tilted the odds from survival to expansion? One answer lies in fire. Archaeological evidence shows a sharp increase in controlled fire use around 800,000 years ago. Fires weren't just occasional wild blazes captured from lightning. They were hearths tended, carried, and mastered. Fire transformed everything. Cooking made tough roots and meats digestible, unlocking calories hidden in otherwise unpalatable food. Flames extended the day, warded off predators, warmed bodies in cold nights. A campfire was more than a tool, it was a multiplier of survival, a force that allowed small bands to live in places that had previously been lethal. Another answer lies in tools. Stone implements became more sophisticated and standardized around this same time. Instead of rough flakes chipped off rocks, we see deliberate shaping of hand axes, scrapers, and points. These tools weren't just functional, they were efficient, designed to stretch effort further. A well-crafted hand axe could butcher a carcass quickly, reduce waste and feed more people. It meant less energy spent for more reward, a crucial improvement for fragile populations. And then there was cooperation. As groups began to stabilize the old survival skills sharing, teaching negotiating scaled upward. Hunting grew more coordinated. Evidence suggests that humans began driving animals into natural traps or working in larger groups to surround prey. Such tactics required trust planning and communication. They also yielded more food supporting more children, fueling faster population growth. Picture the moment of shift. Where once a small band might have starved if they'd failed to catch a gazelle, now a cooperative hunt brought down enough meat to last weeks. Where once children might have died from malnutrition, now cooking and sharing improved survival. Where once fire was a borrowed spark from a lightning strike, now it was a living presence carried from camp to camp, anchoring communities. The genetic data captures this moment. The bottleneck's long flat line gives way to a sharp upward curve, populations climbing, resilience increasing. From that fragile root of about 1-80 breeders, humanity began to stretch its limbs again, reaching out into a world that had almost erased it. In the next part, we'll see how this recovery didn't just restore numbers, it set the stage for a great branching of our lineage. For as our ancestors spread and multiplied, they would diverge into 3 distinct paths, the beginnings of modern humans, the Neanderthals and the Denisovans. The moment populations began to rise again, evolution seized the opportunity to diversify. For over 117,000 years, humanity had been like a river, squeezed through a narrow gorge, pressed, compressed, almost broken. Then around 813,000 years ago, the gorge opened, and that river burst into multiple channels at once. From a single fragile population, 3 great lineages began to flow outward, the ancestors of modern humans, the Neanderthals and the mysterious Denisovans. Think of water rushing from confinement. In one direction it carved new valleys through Africa. In another it surged north into Europe's forests and tundra. In yet another, it spilled east into the vastness of Asia. Each current carried the same genetic signature of survival, the fused chromosome, the scars of lost diversity, the cooperative instincts forged in near extinction. But each current soon met its own landscape, its own trials, its own destiny. In Africa, the descendants who would one day become Homo sapiens adapted to an environment of shifting climates. Droughts gave way to rains, grasslands expanded and shrank, and populations learned to live not by specializing narrowly, but by remaining endlessly flexible. That adaptability became their hallmark. North and west, another branch of survivors entered Europe. There the climate was harsh, cold and seasonal. These humans grew stockier, stronger with broad noses to warm icy air. Over time they became the Neanderthals, masters of Ice Age survival, formidable hunters, who would one day share valleys with our own ancestors. Eastward, a third current flowed into Asia. Their story is more shadow than substance, revealed mostly in fragments of DNA and a few bones from a Siberian cave. These were the Denisovans, who spread astonishingly far into the mountains of Tibet across Southeast Asia, even leaving their imprint in the genomes of Pacific Islanders today. All 3 lineages were kin sprung from the same 1,000 and a few, who had clung to life in Africa. But as they spread into new lands, differences accumulated. Diet, climate, and isolation sculpted their bodies and minds in distinct ways. And yet the genetic bottleneck left them close enough to remain interconnected. When their ranges overlapped, they could still interbreed, exchanging genes that would ripple forward into modern populations. This branching was not the neat separation of species we often imagine. It was messy, like rivers, braiding and rejoining. Genes flowed back and forth, encounters were sometimes violent, sometimes intimate. And yet the overall trajectory was clear. From one narrow root, 3 great trunks began to grow. The Great Split was more than just biology, it was destiny in motion. Each lineage would carry forward different strengths. Each would leave a mark on the human story, but only one, our own, would outlast the others. In the next part we'll follow the branch that remained in Africa, tracing how adaptability in an unstable homeland prepared the ancestors of modern humans to eventually reshape the world. While one branch of our ancestors marched north into the cold and another drifted east into Asia, a third remained in Africa, the very cradle where the bottleneck survivors had endured. It was here in a land of relentless change that the seeds of Homo sapiens were sown. If the Neanderthals would be sculpted by ice and the Denisovans by mountains and seas, then our lineage was forged in the crucible of instability itself. Africa during this period was not kind. The climate never settled into predictable rhythms. Rainfall waxed and waned, grasslands advanced and retreated, and forests flickered in and out of existence. The land was a mosaic in constant rearrangement, forcing those who lived there to become generalists able to adjust quickly, able to survive where others would perish. Adaptability became not just a skill, but a survival requirement baked into our biology across countless generations, and adaptability favoured the mind. In a world where food sources shifted, where prey disappeared and new plants emerged, intelligence was as valuable as strength. Those who could solve problems creatively, who could find a new route to roast when old ones failed, who could craft a sharper tool from an unfamiliar stone, who could read the shifting patterns of weather and migration were the ones who kept their children alive. Natural selection leaned heavily toward flexibility, foresight, and cooperation. It is in this African crucible that we begin to see the faint foundations of symbolic thinking. No cave paintings yet, no carved figurines, but the raw material was forming. The ability to recognize that a mark in the dirt could represent something, that a sound could stand for an idea, that a gesture could carry meaning beyond the immediate. These were skills that turned survival knowledge into shared memory. They laid the groundwork for language, for teaching, for culture itself. Tools too were evolving. Hand axes became more refined flakes struck with greater precision. Standardized design spread across regions, suggesting that knowledge was not only being invented but transmitted. The stone in your hand was no longer just a rock, it was an idea you could share, a technique you could pass on, a legacy you could give to your children. Over hundreds of thousands of years, this slow accumulation of mental adaptability, problem-solving, and innovation shaped a lineage unlike any other. The African survivors weren't the strongest. They weren't the largest. They weren't even the most widespread. But they were becoming something far more dangerous, a species that could imagine possibilities, adapt strategies, and reshape tools to fit new challenges. This was the path toward modern humans, Homo sapiens. It wasn't destiny, but it was momentum. Africa's shifting landscapes pressed the mind into sharper focus, refined the instincts for cooperation, and demanded a creativity that would much later allow our species to spread across every corner of the Earth. In the next part, we'll leave Africa for a time, and follow the northern branch, the Neanderthals, who are adapting to their own challenges in the frozen landscapes of Ice Age Europe. As one branch of our shared ancestry remained in Africa, another pushed into a world that could not have been more different. These were the ancestors of the Neanderthals moving north and west into the frozen landscapes of Ice Age Europe and Western Asia. If Africa was a land of shifting climates and forced adaptability, Europe was a crucible of cold where survival required toughness and specialization. The Neanderthals adapted with astonishing speed. Their bodies became robust and powerful, built to withstand bitter winters and the grinding demands of Ice Age life. Stocky frames conserved heat, dense bones and immense muscle mass gave them the strength to hunt enormous prey. Their faces projected forward with large nasal passages that acted as natural heaters, warming and moistening the icy air before it reached their lungs. These were not frail survivors clinging to life, they were titans of the north, perfectly tuned for their environment. And their minds were no less impressive. Neanderthals carried brains as large and often larger than modern humans. Their cognitive abilities may have been channeled differently, focused on spatial awareness, hunting strategies, and practical survival, but they were far from primitive. Archaeological evidence paints them as master hunters, working in coordinated groups to bring down Ice Age giants, mammoths, bison, and woolly rhinoceroses. They wielded carefully crafted spears, sometimes hafted with stone tips fixed into wooden shafts with resins and sinew. These were weapons of deliberate design made for thrusting at close range against animals that could kill with a single charge. But the Neanderthals were more than just hunters. They were capable of tenderness and ritual. In caves scattered across Europe, archaeologists have uncovered burial graves where Neanderthals intentionally placed their dead. Some bodies were positioned carefully, others accompanied by tools or flowers. These acts suggest more than practicality. They hint at symbolic thought, at a recognition of death as something meaningful, perhaps even a first glimmer of spiritual imagination. Picture the scene: a group gathered around a shallow grave dug into the cold earth. They place a body within, not discarded, but arranged with care. Perhaps there are murmurs of sound, gestures of respect. In that moment you can almost hear the echo of something deeply human, an acknowledgement that life has significance beyond its physical end. For tens of thousands of years, the Neanderthals thrived in Europe and Asia, holding dominion over lands that modern humans had not yet reached. They were strong, intelligent, and culturally rich in their own way. When our ancestors eventually crossed paths with them, It would not be an encounter with brutes, but with equals different in form and emphasis, yet carrying the same legacy of survival through the ancient bottleneck. In the next part, we'll follow the third branch of this great split, the enigmatic Denisovans known mostly not by their bones, but by their dough whose legacy still lingers in people across Asia and Oceania today. The third branch of that ancient split moved eastward, spreading across the immense landscapes of Asia. These were the Denisovans, a lineage as real as the Neanderthals, yet wrapped in mystery. For decades no one even knew they existed. Unlike their cousins, they left behind few fossils. A finger bone, a tooth, a fragment of skull just whispers in the soil, but in those fragments lay DNA, and that DNA revealed an entire lost people. The Denisovans adapted to environments as varied as Asia itself. Some ventured into the high plateaus of Tibet, where thin air and low oxygen challenge even modern climbers. Their genetic traces tell us they developed unique adaptations that allowed them to thrive at extreme altitudes. Today, those same genes still live in Tibetan populations, giving them remarkable resistance to hypoxia. In a sense, when you see monks in Lhasa or shepherds tending yaks on Himalayan slopes, you're witnessing Denisovan survival written into modern blood. Other Denisovan groups seem to have embraced the sea. Evidence suggests they reached islands in Southeast Asia that would have required deliberate navigation and seafaring skills. Imagine rough-hewn boats crossing straits under starlight, carrying small groups into new lands. These voyagers may have been among the first humans to treat the ocean not as a barrier, but as a pathway. Their genes linger too in Pacific Islanders, in people of Papua New Guinea and Aboriginal Australians. In some of these populations, as much as 6% of their DNA is Denisovan. Though their bones are scarce, their legacy is everywhere. When modern humans spread across Asia tens of thousands of years later, they interbred with Denisovans, inheriting survival traits that still benefit us today. Genes that help process oxygen at altitude, resist certain diseases, and metabolize new diets. We carry fragments of their story in our cells, proof that they weren't just shadows but vital contributors to who we are. If Neanderthals were the masters of ice and modern humans the children of adaptability Denisovans were the explorers stretching from Siberia to the Pacific, shaping human evolution in places where history left few physical traces. Their story is still being pieced together, not with shovels in the dirt, but with sequencers in laboratories extracting echoes of life from fragments that might otherwise have been forgotten. And so from that single population of 180 survivors came three great human currents: the adaptable lineage in Africa, the robust Neanderthals in Europe, and the elusive Denisovans in Asia. Each carried the scars of the bottleneck, each bore the fused chromosome, each was kin. But only one would eventually circle the globe. In the next part, we'll explore how, despite their divergence, these lineages were never entirely separate. How they met, mingled, and exchanged genes, leaving traces of their ancient encounters in all of us. Even as the human family tree split into three great branches, those branches never grew in perfect isolation. They bent toward each other, crossed and sometimes twined together again. For hundreds of thousands of years, the Neanderthals, Denisovans, and the African lineage that would become modern humans remained interconnected, yet divergent, distinct species in the making, but still close enough to share blood. The proof lives inside us. Every person of non-African descent today carries about 2% Neanderthal DNA. In parts of Asia and Oceania, many also carry Denisovan DNA, sometimes as much as 10. These are not statistical curiosities. They are genetic heirlooms, remnants of ancient encounters where our ancestors met their cousins and formed bonds that were more than just competition for land or prey. Picture the scene. A band of early modern humans moves into a valley long held by Neanderthals. Tensions flare perhaps at first, but over time curiosity overcomes fear. Bonds form. Children are born who bridge two lineages. Their descendants thrive, carrying forward traits from both parents: stronger immune responses here, altitude tolerance there. The genome became a kind of woven tapestry, each thread representing both divergence and reunion. This interbreeding was possible because of the bottleneck. That near-death squeeze had left all three groups genetically close, carrying the same fused chromosome, the same reduced variation. They had diverged, yes, but they were still kin branches split not so long ago, still flexible enough to graft together when contact allowed. Far from being neat, the story of human evolution is messy, tangled, and profoundly human. It is not a tale of clean separations, but of connection through difference. Even as Neanderthals mastered icy forests, Denisovans claimed mountains and seas, and our lineage adapted to Africa's shifting climates, they remained one family in a deep sense. And this family unity mattered. It meant survival traits could be shared across groups. Denisovan altitude genes kept Tibetans alive in the thin air. Neanderthal immune adaptations helped early humans weather Eurasian pathogens. The bottleneck had narrowed us all into one fragile stream, but that shared origin ensured that when the streams split, they still recognized each other as kin. In the next part, we'll see how this interconnected family tree fueled not just survival but innovation, as each lineage contributed to an explosion of technological and cultural creativity across continents. Once the grip of the bottleneck loosened and populations began to grow, something extraordinary happened, not in one place, but across the branches of the human family tree. Almost as if awakened from a long slumber, technology began to flourish. In Africa, Europe, and Asia, 3 different lineages, modern human ancestors, Neanderthals and Denisovans, each made parallel leaps forward, evidence of minds under pressure, solving problems in remarkably similar ways. In Africa, stone tools became more than rough shards. They were standardized, crafted with precision, their shapes and sizes nearly identical across wide regions. This was a sign not just of skill but of cultural transmission. Knowledge was being shared, taught and preserved in a way that transcended individual survival. A stone axe was no longer only a tool, it was an idea passed from hand to hand, from generation to generation. In Europe, the Neanderthals pushed toolmaking to new heights. They developed the first hafted weapon stone points carefully bound to wooden shafts using animal sinew and natural glues. This wasn't improvisation, it was engineering. To make such tools you had to plan ahead, gather materials from different places, and understand that combining them created something greater than the parts. With these spears, Neanderthals became master hunters capable of bringing down massive Ice Age prey through coordination and force. Meanwhile in Asia, the Denisovans may have taken yet another path. Though their bones are few, their genetic echoes hint at surprising skills. Some researchers suspect they pioneered the systematic use of medicinal plants, passing down knowledge of which roots soothed illness, which leaves reduced pain, which barks fought infection. There are even tantalizing suggestions that Denisovan groups experimented with early cultivation of grains, thus laying a fragile foundation for the idea of agriculture long before it truly flourished. Whether or not this was full farming, it shows minds leaning toward reshaping nature itself. Seen together, these advances paint a picture of shared cultural leaps scattered across continents yet driven by the same pressures. When food was scarce, when survival demanded efficiency, human lineages everywhere began to innovate. Fire-hafted tools, medicines, storage and shared teaching. All of these were born in response to the harsh lessons of the bottleneck. It is a reminder that technology was never about luxury. It was survival distilled into ingenuity. Every chipped stone, every bound spear, every bitter plant chewed for healing was a direct answer to the ancient question, how do we endure one more season, one more hunt, one more generation? In the next part, we'll explore how these innovations did more than feed and protect. They also changed the way humans lived together, giving rise to more complex social structures that would set the stage for everything that followed. As tools grew sharper and fires burned longer, survival demanded more than individual skill. It required something even more powerful, the weaving together of lives. Out of scattered bands of 20 or 30 individuals, new patterns of cooperation began to emerge. These weren't just families anymore. They were the first stirrings of social complexity. Archaeological and genetic evidence suggests that small groups weren't isolated bubbles. They formed trade networks, sometimes stretching hundreds of miles. Obsidian from one valley shows up in tools far beyond its source. Shells from the sea appear inland. Pigments move between regions. These objects weren't just practical, they were proof of connection tokens carried across dangerous landscapes to bind one group to another. Kinship became structured. Instead of random mating within a band, early humans began practicing systematic exchange of marriage partners. Genetic studies show patterns of structured breeding, suggesting rules perhaps unspoken at first about who could pair with whom. This wasn't about romance, it was about survival. By linking groups through marriage, fragile populations created webs of trust and obligation that reduced inbreeding and increased resilience. Picture a meeting of 2 bands at the edge of a river. Goods change hands, a stone tool for a bundle of dried roots, a skin for a piece of obsidian. But there's more at stake. A daughter joins another band, a son finds a mate across the water. With each union, the groups become entwined, less likely to fight, more likely to aid each other in lean years. Each marriage is a peace treaty, each trade a promise of return. This social glue was as crucial as fire or tools. It allowed populations to scale up to hold together not just as families but as communities. Over time, these alliances expanded into larger networks, the faint beginnings of tribes with rules, traditions, and expectations that bound individuals into something greater. And with social complexity came something remarkable, the ability to share knowledge across distances and generations. Technique invented in one valley could be taught to allies in another. A story told by fire in one camp could shape decisions in a camp hundreds of miles away. Culture began to move faster than genes, and with it the pace of human adaptation accelerated. In the next part, we'll see how this accelerating web of connection may have laid the groundwork for the most profound leap of all, the birth of true language, the tool that would make everything else possible. In the long shadow of the bottleneck, survival depended on more than sharp tools or warm wires. It depended on the ability to share ideas, to pass knowledge across generations, to coordinate hunts, to teach children the fragile map of waterholes and edible roots. Out of this necessity, the most powerful tool of all began to take shape: language. Nobody knows exactly when human speech emerged. It doesn't fossilize like bones or stone, but evidence points to the post-bottleneck world as the crucible where communication evolved beyond simple gestures and calls. Imagine tiny scattered groups separated by miles of harsh terrain. They needed to maintain connections to trade, to exchange marriage partners. A grunt or a gesture wasn't enough. Survival demanded nuance. It demanded words. The bottleneck may have accelerated this process. In a population so small, every innovation spread rapidly. If one group developed clearer sounds to describe a tool or a plant, those sounds could spread through the network within a few generations. When survival hinged on accurate information, knowing which tuber was poisonous or when the rains would return, the ability to communicate precisely meant the difference between life and death. Language was a survival advantage. It allowed hunters to coordinate more effectively, surrounding prey with strategy instead of chance. It let elders teach children not just through demonstration, but through explanation, compressing years of trial and error into a few spoken lessons. It gave groups the ability to negotiate, to form alliances, to diffuse conflicts before they became deadly. And language did something else, something that would forever set us apart. It opened the door to imagination. Once words existed, you could describe not just what was in front of you, but what was absent, what was possible. You could tell a story about the past, warn of dangers in the future, or even invent meanings that reached beyond survival, meanings that would one day blossom into myth, art, and culture. Picture a group of early humans gathered around a fire. The flicker of flames reflects in their eyes as one elder speaks, describing the path to a hidden spring or the signs of game on the move. Younger faces lean forward, absorbing every detail. The words may have been rough, more sound than sentence, but the message is clear. Knowledge flows not through blood alone, but through speech. In that moment, survival becomes collective, shared through sound carried on the air. From these beginnings, language became the ultimate inheritance of the bottleneck. A tool more flexible than stone, more enduring than fire. It was the key that unlocked everything to come. In the next part, we'll explore how, armed with language and cooperation, humans began to spread outward again, eventually colliding with their cousins, the Neanderthals and Denisovans, in encounters that would shape our shared destiny. For hundreds of thousands of years after the Great Split, the three human lineages lived mostly apart. Modern human ancestors adapting within Africa, Neanderthals mastering the cold of Europe, Denisovans spreading across Asia. But separation could not last forever. Around 60,000 years ago, a small band of Homo sapiens began to move out of Africa, carrying with them the legacy of adaptability honed through endless cycles of hardship. What followed was an age unlike any before the age of competition. The first crossings were small, perhaps just a few hundred people slipping along coastlines or through fertile corridors in the Middle East. To them, the world beyond Africa was new and dangerous, but not empty. In the valleys and caves of Europe, Neanderthals had lived for generations, hardened hunters with strength and intelligence to match. In the highlands and forests of Asia, Denisovans thrived, their genes were all sculpted by mountains, seas, and open plains. When modern humans arrived, they were not stepping into wilderness. They were entering occupied territory. What those first encounters looked like, we will never know. Perhaps curiosity tempered fear, perhaps violence sparked immediately. Likely it was both. Archaeology and genetics tell us the outcomes there was conflict, yes, but also cooperation. Modern humans and Neanderthals interbred repeatedly, leaving traces of shared children in our DNA. Denisovan genes too became woven into our genome, especially in Asia and Oceania. These unions weren't isolated flukes, but repeated interactions across millennia. Yet alongside intimacy there was rivalry. Groups competed for the same rivers, the same hunting grounds, the same caves that offered shelter from winter winds. Neanderthals had been perfecting their Ice Age strategies for over 200,000 years. Denisovans had carved out niches from Siberia to Southeast Asia. Modern humans entered this contest not as the strongest or most specialised, but as the most flexible, able to adapt, innovate and endure shifting climates better than any cousin. The stage was set for a long struggle. For tens of thousands of years, three kinds of humans coexisted, sometimes sharing, sometimes clashing, always shaping one another's fate. But only one lineage would eventually claim the future. Not because the others were weak, they were formidable, but because the bottleneck had left modern humans with something different. A relentless adaptability sharpened by instability, amplified by their language, and carried in every step of their migrations. This was the beginning of the end for Neanderthals and Denisovans, and the dawn of an age when one branch of humanity would rise to dominance. In the next part, we'll watch that struggle unfold, tracing how modern humans, armed with new tools and strategies, gradually gained the upper hand against even the strongest of their cousins. The first meetings between modern humans and Neanderthals likely happened in the Middle East, where the ranges of the two species overlapped. Picture the scene: a small band of Homo sapiens emerging from Africa, following game along the Levantine corridor, perhaps moving north along rivers or hugging the coast. Ahead in the hills and caves lived beings that looked eerily familiar. They were not predators nor prey, but something in between, almost human, yet not quite. Imagine the awe of that moment. To see another creature standing upright, walking as you do, using tools, tending fire. Their faces carried heavy brow ridges, their frames more massive, their movements powerful and sure. They were strangers, but they were not other in the way animals were. They were kin in some deep, unsettling way. Curiosity and fear must have mixed in equal measure. What happened next is written in our genes. There was conflict, almost certainly contests for waterholes, for caves, for hunting grounds. But there was also contact of another kind. Modern humans and Neanderthals interbred, and not just once. Genetic evidence reveals multiple episodes of mixing enough that today every non-African alive carries about 2% Neanderthal DNA. These were not isolated encounters, but repeated unions, bonds formed across millennia of shared territory. That 2% is more than a number. It is a living record of intimacy and exchange. It means that when you look in the mirror, fragments of your genome come from Neanderthals' genes that helped early humans adapt to colder climates, to new pathogens, to unfamiliar diets. The Neanderthals are gone, but they live on in not as shadows in caves, but as sequences of tea curled in every cell. For tens of thousands of years, this coexistence shaped both species. Sometimes the relationships were cooperative, sometimes hostile, but always consequential. The Middle East became a revolving door where Neanderthals and humans alternated control depending on climate shifts. Each migration brought new encounters, new minglings, new rivalries. It is humbling to realise that the story of us is not only about triumph, but about entanglement, a lineage braided together with cousins who vanished, but never entirely. The first meetings were not just turning points in history. They were moments when the definition of human itself became more fluid, more expansive, written not only in memory, but in blood. In the next part, we'll follow these encounters deeper into Europe, where competition for survival intensified, and the eventual decline of the Neanderthals began to unfold. For millennia after those first encounters in the Middle East, Neanderthals and modern humans lived in a fragile balance. Climate shifts swung the pendulum of dominance back and forth. In colder, harsher periods, Neanderthals often prevailed, their stocky bodies and Ice Age strategies honed to perfection. When climates warmed, modern humans pushed northward, their adaptability giving them an edge. Territory changed hands like a tide valley's caves and hunting grounds flowing from one lineage to the other. But over time, something began to tip the scales. Modern humans, shaped by generations of instability in Africa, were relentless innovators. Around 45,000 years ago, they unveiled what archaeologists call the Upper Paleolithic Toolkit, a suite of technologies that would redefine survival. First came the spear thrower, or atlatl, a simple lever that transformed hunting. With it, a hunter could hurl a spear with greater speed, distance, and accuracy than ever before. What once required risky close-range thrusts now became a deadly strike from afar. Neanderthals who relied on powerful bodies and thrusting spears suddenly found themselves at a disadvantage. Then came fitted clothing. With bone needles, humans stitched garments tailored to the body far more efficient than draped hides. These clothes conserved heat, opened up colder regions to settlement, and freed modern humans from the limits of climate that bound others. There were also fishhooks and nets tools that unlocked entire new food sources. Rivers and coastlines became rich pantries providing steady nutrition even when big game was scarce. Neanderthals so focused on large land mammals could not match this diversification. And perhaps most transformative of all, blade technology. Instead of chipping crude flakes, humans learned to strike long sharp blades from stone cores. These blades could be reworked into knives, scrapers and points, multiplying the uses of a single piece of flint. It was efficient, flexible and scalable, the hallmarks of innovation under pressure. Together, these advances gave modern humans a compounding advantage. Smaller groups could achieve what once required larger numbers. A handful of hunters with atlatls could bring down game that once demanded 20 Neanderthals working in concert. Families equipped with fitted clothing could move into regions previously unlivable. Communities with nets and hooks could feed themselves through lean winters. This was not the sudden conquest of one species over another. It was a slow, grinding shift. Every new innovation widened the gap. Every generation that adopted these tools gained a little more resilience, a little more security. Bit by bit, Neanderthals were pressed into more marginal lands, their dominance chipped away not by brute force, but by the quiet power of technology and adaptability. In the next part, we'll follow this long contest to its conclusion, the decline of the Neanderthals, the survival of their DNA, and the rise of modern humans as the last branch standing. For tens of thousands of years, the Neanderthals held their ground against the newcomers. They were not fragile, nor were they helpless. They were strong, intelligent, and resourceful. But as modern humans spread deeper into Europe, the competition intensified. The rich river valleys, fertile hunting grounds, and sheltered caves that had sustained Neanderthals for millennia were gradually claimed by Homo sapiens. Archaeological evidence tells a grim story. Skeletal remains from both Neanderthals and early modern humans sometimes bear the unmistakable marks of violence, skull fractures, embedded spear points, wounds from close combat. These scars suggest that the two species did not only meet as partners in interbreeding, but often as rivals in battle fighting for the same land and the same prey. The Neanderthals resisted fiercely. For a time they even pushed humans back when climates shifted in their favour. But the balance was uneven. With each passing millennium, the innovations of modern humans, their spear throwers, fitted clothing, fishing nets and blade tools allowed them to thrive where Neanderthals merely endured. Slowly, steadily, the Neanderthals were forced out of the prime territories and into the marginal lands, colder uplands, less fertile forests, places with fewer resources. The final redoubt of the Neanderthals lay in the far southwest corner of Europe, southern Spain and Gibraltar. Here, sheltered between the sea and the mountains, they clung to existence long after their kin elsewhere had vanished. Imagine small bands hunting along rocky coastlines, gathering shellfish, eking out survival at the edge of the continent, while modern humans expanded across Europe in growing numbers, but even this refuge could not last forever. Around 28,000 years ago, the last Neanderthals disappeared. Not with a single catastrophic event, but with the slow attrition of dwindling numbers, shrinking territories, and relentless pressure from modern humans. Their extinction marked the end of one of humanity's closest cousins, a lineage that had thrived for hundreds of thousands of years, only to fade when faced with a rival more adaptable, more connected, and more numerous. And yet the Neanderthals are not entirely gone. They live on in us in the DNA stitched into every non-African human alive today. Every time you fight off an infection or adapt to a cold climate, you may be calling upon genes that first evolved in Neanderthal bodies. Their legacy persists not in their bones, but in our blood. In the next part, we'll turn eastward to Asia, where the Denisovans survived even longer, in scattered enclaves leaving behind not only fragments of fossils, but living echoes in the people of today. While Neanderthals held Europe, the vastness of Asia belonged in part to the Denisovans, the most mysterious of our cousins. Unlike the Neanderthals, whose bones fill caves across the continent, the Denisovans left behind almost nothing. A single finger bone in Siberia, a few teeth and fragments of skull. And yet from these scraps, DNA has revealed a lineage that once spanned half a world. The genetic evidence is unmistakable. Modern populations across Asia and Oceania carry Denisovan DNA. In some Pacific Islanders, and indigenous Australians, as much as 6% of their genome comes from Denisovans, these genes are not curiosities, they are survival tools. One variant passed on to Tibetaners allows the body to use oxygen more efficiently at extreme altitudes, making life on the Himalayan plateau possible. Other genes may have helped early humans resist new diseases or adapt to unfamiliar diets. This tells us that when modern humans spread eastward, they did not move into empty lands. They encountered Denisovans in forests, on mountainsides and along coasts. In some places they fought for territory, in others they mingled, forming families and passing down children whose bloodlines flowed into the future. Just as with Neanderthals, the story was not one of simple replacement, but of absorption and entanglement. The Denisovans seemed to excel at surviving in niches where others struggled. Some made homes in the thin air of mountain ranges, their physiology tuned to heights that would leave most gasping. Others may have mastered seafaring, crossing straits to settle distant islands in Southeast Asia, long before modern humans learned to do the same. They were survivors, explorers in their own right, spreading across a staggering range of environments. But the same forces that doomed the Neanderthals eventually reached them as well. Modern humans, with their adaptable toolkits, complex social systems and expanding numbers, gradually outcompeted Denisovans across their territories. Some groups may have endured in isolation for tens of thousands of years, but one by one they were absorbed into the rising tide of Homo sapiens. And so the Denisovans faded not into extinction as cleanly as the Neanderthals, but into inheritance, their genes braided into ours. Today, when a Sherpa guides climbers up Mount Everest, or when Pacific Islander communities trace their heritage to ancient voyagers, they carry with them whispers of Denisovan blood. In the next part, we'll see how by about 20,000 years ago, only one human lineage remained our own, and how the final dominance of modern humans reshaped the fate of the planet forever. By about 20,000 years ago, the world's stage had narrowed to a single caste modern humans. The Neanderthals had vanished, the Denisovans had been absorbed, and only one lineage of our ancient family tree remained. But why us? Why did our branch endure when others, just as intelligent and resilient, faded into history? The answer lies in a single word: flexibility. Modern humans were the consummate generalists. When Neanderthals relied heavily on large Ice Age mammals, we learned to eat anything. Shellfish, berries, roots, fish, small game. If one food vanished, we pivoted to another. Where Denisovans mastered mountain ridges or distant islands, we adapted to both moving easily between forests, grasslands, coasts and deserts. Our social networks were another decisive edge. Neanderthal groups tended to be small and tightly knit, effective in close cooperation, but limited in scale. Modern humans built webs of connection stretching far beyond the immediate band. Trade moved stone shells and pigments across hundreds of miles. Marriage partners linked distant groups, ensuring genetic diversity and creating alliances. In times of hardship, those networks could be lifelines, offering resources and information from afar. Then came innovation, faster, broader, more relentless. Neanderthals crafted superb tools, but their technology often remained stable for thousands of years. Modern humans, by contrast, seemed restless, constantly experimenting, refining and spreading new techniques. From spear throwers to fishing nets to tailored clothing, our innovations cascaded across populations with dizzying speed. And underpinning all of this was language. Not just signals or shared calls, but complex structured speech capable of carrying nuance, teaching detail and preserving memory. Language allowed knowledge to move across generations intact, accelerating cultural evolution beyond what genetics alone could achieve. It was the invisible infrastructure of survival, letting small groups coordinate hunts, negotiate peace and share the wisdom of elders long after they were gone. One archaeologist once described the comparison this way: Neanderthals were like racing cars finely tuned for a single track. Modern humans were like all-terrain vehicles able to handle anything the world threw at them. The Neanderthals were specialists unmatched in Ice Age hunting. The Denisovans were explorers of extremes adapted to mountains and seas, but modern humans were adapters, innovators, connectors, never the best at one thing, but capable of surviving at almost everything. And when climates shifted, when resources changed, when new challenges arose, that flexibility always won. It wasn't raw strength that carried us forward, but a kind of evolutionary versatility, a readiness to bend to change, to imagine something new. In the next part, we'll step back and see how this flexibility fueled humanity's spread across the globe, from deserts to tundra to islands thousands of miles from any mainland. By 15,000 years ago, the story had changed completely. The fragile spark, once sheltered by just over 1,000 survivors, had become a blaze spreading across the globe. Modern humans, armed with adaptability, ingenuity and language, now occupied nearly every habitable continent. In Africa, where our lineage first endured, the bottleneck populations flourished, moving between deserts, savannas and forests with equal skill. Across Europe and Asia, humans filled the landscapes once ruled by Neanderthals and Denisovans, carrying their DNA even as they replaced their presence. By this time, bands of hunter-gatherers had crossed into Siberia, following herds across frozen tundra. Others, driven by the same restless curiosity, walked the land bridge into the Americas. Within millennia, humans were spreading across North and South America, adapting to everything from Arctic ice fields to Amazonian jungles. Even the seas, once barriers, became pathways. Rafts and simple boats carried us to islands in Southeast Asia and beyond. By the late Ice Age, humans had reached Australia, and eventually even the farthest stretches of the Pacific. The world that had nearly crushed our ancestors was now mapped in footprints and hearthfires. This global spread wasn't just a matter of movement, it marked the dawn of new ways of living. In fertile river valleys, people began experimenting with agriculture. Seeds once gathered became crops deliberately planted. Herds once hunted were corralled and bred. The transition was slow, uneven and fragile, but it signalled the start of settlements, villages and eventually cities. From tiny refuges of 1,000 souls to millions spread across continents, humanity had achieved what once seemed impossible dominance over the Earth itself. Not dominance in the sense of invulnerability. We remained vulnerable to famine, disease and disaster, but in sheer reach. No other large species had ever spread so widely, so quickly, into such a vast array of environments. It is staggering to imagine that every single person alive at that time, whether in the caves of Europe, the plains of Africa, the coasts of Asia or the mountains of the Americas, descended from the same narrow bottleneck. The scattered bands of Ice Age hunters carried forward the legacy of survival, stretching it across the entire planet. In the next part, we'll bring the story into sharper focus, not just the spread of humans, but what our DNA still remembers from those desperate millennia. The scars of fragility, the strengths of adaptability, and the lessons our ancestors left us in blood and bone. If there is one trait that sets humanity apart, it isn't just tool-making or fire, it's cooperation on a massive scale. Unlike our primate cousins, whose groups rarely exceed a few dozen before fracturing. Humans can collaborate in bands, tribes, nations, even civilizations numbering much in the millions. That ability didn't appear by chance. It was forged in the crucible of the bottleneck. When populations shrank to fewer than 1/300 breeding individuals, their survival hinged on unity. In groups so small, every life mattered. Every quarrel threatened stability. Every loss of knowledge endangered the future. Natural selection in those fragile millennia rewarded not the selfish or the violent, but the cooperative. Individuals who could share resources, food from a lucky hunt, water from a hidden spring, helped their entire band endure. Those who hoarded or refused likely saw their line end when their group collapsed. Over time, the instinct to share became deeply rooted in human behaviour. Even today, in communities struck by disaster, people instinctively pull resources and aid one another. That reflex is the echo of survival strategies nearly 1,000,000 years old. Teaching too became essential. In a world where losing one elder could mean the loss of crucial knowledge, how to prepare a poisonous root safely, how to track game across barren ground, the ability to transmit information across generations determined survival. Children who learned quickly lived to pass on their genes. Adults who taught effectively ensured their group's continuity. Across millennia, this created what we might call the human teaching instinct, a drive to explain, to demonstrate, to ensure others carry forward what we know. And perhaps most importantly, humans evolved the ability to cooperate beyond the immediate circle of kin. Structured marriage exchanges, alliances between groups and trade networks forged webs of trust and obligation that stretched across landscapes. Where chimpanzees treat outsiders as rivals, humans learned to treat them as potential partners. That shift, nurtured by necessity in the bottleneck, gave us the capacity to scale up cooperation far beyond anything seen in the animal kingdom. This is why thousands of generations later, humans can build cities, wage wars, and create global networks like the internet. The capacity for large-scale collaboration was born not in abundance, but in scarcity when survival demanded that small groups work together or vanish. In the next part, we'll explore another legacy of the bottleneck, our insatiable drive to teach and learn, the cultural engine that turned fragile bands of survivors into a species capable of passing knowledge through thousands of years. Among all the legacies of the bottleneck, one of the most profound is our compulsion to teach and to learn. In those fragile millennia when human numbers hovered near extinction, survival didn't depend only on strong arms or sharp tools, it depended on the ability to pass knowledge forward. Imagine a child in a small band of survivors. If she failed to learn where to find water in the dry season, or how to prepare a toxic tuber to make it edible, her mistake could cost not just her life, but weaken the group as a whole. There was no margin for error. Elders had to ensure that every child carried the full map of survival in their minds. And so teaching became not a luxury but an instinct. Those who could explain, demonstrate and repeat until the young understood gave their lineage a better chance. Those who didn't, their knowledge died with them. Over tens of thousands of years, this pressure carved itself into our nature. That is why modern humans are so unusual among animals in our obsession with education. Chimpanzees and orangutans teach through demonstration, but not systematically. Humans, by contrast, devote years, sometimes decades of life to schooling. We create apprenticeships, classrooms, mentors, lectures. We even invent fictional stories as lessons embedding survival wisdom in myth and tale. This is no coincidence. It is the echo of a time when oral tradition was the lifeline of humanity. Words around a fire were more than entertainment. They were the vessels of accumulated memory, which plants healed and which killed. Where herds moved in dry years, how to track, how to build, how to endure. Each story told to children was an investment in the group's survival. Forgetting was death, remembering was life, and this teaching instinct scaled with language. Once words became rich enough to describe not just actions but abstractions, humans began to share not only how but why. They speculated, theorized, warned, imagined. Storytelling became the bridge between lived experience and inherited wisdom. We tell stories today through novels, films, even bedtime histories, for the same reason our ancestors told them. Beside flickering flames to transmit knowledge, values, and cautionary lessons across generations. That is why education feels so deeply human, so natural that we rarely question it. Why parents instinctively teach, why communities invest in schools, why stories resonate across cultures. These are not quirks of civilization, but ancient adaptations born in an age when the loss of a single lesson could doom an entire group. In the next part, we'll explore another inheritance from the bottleneck, our unparalleled skill with tools, and how the drive to manipulate the material world may have been sharpened in those desperate centuries of survival. If language was the invisible infrastructure of survival, then tools were its tangible counterpart. Long before we built cities or carved monuments, we chipped stone-shaped wood and harnessed fire. But during the bottleneck, tool-making became more than craft. It became a lifeline sharpened by desperation. In a world where food was scarce and every mistake could mean starvation, the ability to solve problems with objects became the defining edge. A sharp flake might open marrow-rich bones. A shaped axe might cut through roots that sustained life in the dry season. A smouldering branch might preserve fire through days of wandering. Each innovation stretched survival further, buying time for the group, carving another notch in humanity's story. The crisis forged a mindset to see the environment as raw material waiting to be transformed. A river wasn't just water, it was a source of fish reeds for weaving stones for napping. A tree wasn't just shelter, it was fuel spear shafts digging sticks. Even the bones of animals weren't waste, they were needles, awls, ornaments and weapons. Where other animals adapted their bodies to survive, humans adapted the world around them. This relentless problem-solving left its mark in archaeology. Stone tool traditions grew more precise and standardized. Hafting, a complex innovation that bound stone points to wooden shafts spread through populations. Fire, once borrowed from lightning, became something tended, transported, and eventually mastered. Each step represented not just ingenuity, but cultural memory knowledge taught and retaught until it became second nature. And this legacy has never left us. Even today, humans instinctively look at problems and ask, what can I build, what can I use? How can I change the world to suit me rather than change myself to suit the world? That reflex is the echo of those desperate millennia, when survival meant transforming whatever lay at hand into a weapon, a tool or a solution. It's why we can move seamlessly from chipping flint to forging steel, from shaping bone to designing microchips. The bottleneck didn't just preserve our species, it honed us into the world's greatest toolmakers, an identity that has shaped everything from the first hearth fires to the International Space Station. In the next part, we'll examine the darker side of that legacy, how the same narrowing of genetic diversity that gave us resilience also left us unusually vulnerable to disease, a weakness that still lingers today. For all the strengths honed in the bottleneck, cooperation teaching toolmaking, there were also deep genetic costs. A population reduced to barely more than 1,000 breeding individuals could not help but lose much of its variation. And in evolution, variation is the raw material of resilience. Without it, vulnerabilities take root. One of the most profound consequences was our susceptibility to disease. Other primates with larger and more genetically varied populations often possess broader immune defences, but humans thinned by the bottleneck carry far fewer variants in the genes that regulate immunity. That's why epidemics from ancient plagues to modern pandemics spread so devastatingly fast among us. Pathogens exploit shared weaknesses, and with our limited immune diversity, millions can be struck in the same way all at once. Then there are the genetic disorders that should have vanished, but instead became permanent residents of our DNA. In larger populations, harmful mutations are often diluted or eliminated, but in a small isolated group, chance alone can allow them to persist and even spread until they become embedded in the genome. Today, conditions like cystic fibrosis, sickle cell anemia, and certain neurological disorders may carry their roots back to this ancient narrowing. They are the scars of survival written into us not by choice, but by necessity. It is sobering to realise that our genetic fragility is not a recent phenomenon, but a legacy almost 1 million years old. Every time a new virus sweeps the globe, every time a family confronts an inherited disorder, we are touching the echoes of that bottleneck. These weaknesses remind us that survival came at a price, that humanity did not escape the narrowing unscathed. And yet even here there is paradox. Some of these weaknesses also provided unexpected advantages. The sickle cell trait, for example, offers protection against malaria. Other mutations may have carried hidden benefits that helped survival in specific regions. The bottleneck locked in both flaws and gifts, blending them into the inheritance of every human alive today. So in our very DNA we carry a dual message: we are fragile yet enduring, scarred yet thriving. Our weaknesses are the shadows of an ancient struggle, reminders that survival was never guaranteed, but was purchased through sacrifice. In the next part, we'll see how these scars alongside our strengths have shaped the storytelling instinct, humanity's way of turning memory into meaning and struggle into lessons for the future. One of the most striking lessons of the bottleneck is that it leaves no room for illusions of deep division within our species. For all our surface differences, skin colour, hair texture, facial features, all modern humans descend from the same tiny band of survivors, about 1-80 breeding individuals who lived nearly 900,000 years ago. Every person alive today carries their legacy. This fact alone debunks the myths that have long been used to divide humanity. There are no separate biological races in the genetic sense. The variation among us is real, but it is shallow, mere ripples on the surface of a single shared pool. In truth, the genetic diversity within a single troop of chimpanzees is greater than that across the entire human species. That is how severe the bottleneck was, and how tightly it bound us together. What this means is humbling a person in Africa may be more genetically similar to someone in Europe than two chimps from the same forest are to each other. A family in Asia shares the same ancient scars in their DNA as a family in South America. Our differences are recent cosmetic and adaptive responses to sunlight, altitude or diet, not deep divides. The story of the bottleneck tells us that humanity is one extended family. Every face on Earth, no matter how unfamiliar, carries the imprint of those thousand and a few who clung to life through ice ages and droughts. If they had failed, none of us would be here. If even one small band had vanished, our shared story might never have begun again. And yet despite this unity, humans have often built myths of separation stories, of superiority, of pure bloodlines, of inherent difference. The science of our origins offers a clear rebuttal. There is no pure, no fundamental divide. We are quite literally brothers and sisters, cousins many times removed, carrying the same ancient inheritance forward. This truth doesn't erase our cultures, languages or histories. They are vibrant branches grown from the same trunk. But it does remind us that beneath all of it lies a shared root, a narrow survival that binds every human alive today. In the next part, we'll look at how this shared ancestry still resonates in our collective imagination, fueling humanity's enduring instinct for storytelling, a way of remembering who we are and why we endure. From the moment our ancestors began leaving Africa around 60,000 years ago, their descendants carried the same fragile inheritance, the DNA shaped by the bottleneck. Yet as they spread across vastly different environments, this single genetic toolkit unfolded into a spectacular diversity of adaptations. In Australia, early migrants encountered harsh deserts and unpredictable climates. Over tens of thousands of years, their descendants developed darker skin to shield against intense sunlight and honed extraordinary navigation skills to survive in arid landscapes. They became some of the earliest humans to master firestick farming, using controlled burns to shape the land for hunting and gathering. In Europe, the bottleneck's children faced cold seasonal climates. Natural selection gradually favoured lighter skin tones to absorb more vitamin D from limited sunlight, as well as physiological adjustments to endure long winters. These adaptations helped them survive in regions where game animals migrated with the seasons and where food storage became as vital as the hunt itself. Polynesians thousands of years later turned the same inherited toolkit toward the sea. From ancestors carrying bottleneck DNA, they developed matched seafaring traditions. With nothing more than outrigger canoes, star charts, and deep memory, they navigated thousands of miles of open ocean, colonizing the Pacific Islands. Their ingenuity shows how shared human adaptability could blossom into feats of exploration almost unimaginable to those first survivors in Africa. And in the Americas, migrants crossing the Bering Land Bridge around 20,000 years ago carried bottleneck-tested resilience into an entirely new world. They adapted to everything from Arctic tundras to Amazon rainforests, developing countless languages, cultural systems, and survival strategies. The shared genes that once kept small bands alive in African valleys became the foundation for civilizations stretching from the Inca to the Iroquois. These global stories illustrate the same truth, though. Separated by oceans and climates, every population draws from the same deep reservoir of inherited endurance. The differences are local flourishes on a universal theme. Whether surviving under desert suns, icy tundras, or vast oceans, each culture is a living echo of those who endured 117,000 years of near extinction and then flourished in every corner of the earth. Next, we'll explore how this unity masked by diversity still lives in the stories we tell and the traditions we carry, connecting us back to the survivors who began it all. When we look back at the bottleneck, one lesson rises above all: climate change nearly ended us once before. Our ancestors endured an ordeal that stripped Earth of nearly every human life. They faced arid deserts where rivers once flowed, forests that withered into wastelands, and animals that vanished forever. They survived, yes, but only barely. That memory written in our DNA is a stark warning. We are not invincible. The planet does not bend to our ambitions. Even the most successful species can falter when climates shift too far too fast. Today, as ice sheets melt and weather grows erratic, the echoes of 900,000 years ago grow louder. Once again, humanity is staring at a destabilized world. But alongside the warning comes hope. Those tiny bands of survivors didn't have cities, science, or technology. They didn't have agriculture or medicine or satellites mapping global storms. What they had was adaptability, ingenuity, and above all, cooperation. They shared food, fire, and knowledge when the cost of selfishness was extinction. They adapted their tools, diets, and strategies to every change nature hurled at them. Those same traits still live in us. Our ability to innovate, to teach, to work together on scales no other species can match, that is our inheritance. The bottleneck proved that even when survival seems impossible, humans can endure by changing together. So when we face today's challenges, rising seas, shifting climates, dwindling biodiversity, we are not without guidance. The blueprint is in our past. We survived one climate catastrophe, not by dominating the Earth, but by listening to it, learning from it, and adapting to it as a family. The lesson is simple and urgent. Survival is never guaranteed, but cooperation and flexibility can turn the edge of disaster into the start of resilience. In the next part, we'll explore how the bottleneck is not only a warning, but also a mirror, showing us who we are at our core and what kind of future we might choose to build. The bottleneck is both a warning and a promise, a paradox etched into our DNA. On one hand, it reveals the terrifying fragility of our species. At our lowest point, fewer people roamed the Earth than might fill a small town today. A single epidemic, a volcanic eruption, even a poorly timed drought could have ended us forever. That is how close humanity came to vanishing. We are not untouchable. Our dominance today does not erase the fact that once survival teetered on the edge of a knife. And yet the bottleneck is also proof of something extraordinary resilience under impossible odds. For 117,000 years, tiny groups of early humans endured. They adapted diets, invented ways to find water, learned to use fire more wisely, and built fragile but vital social bonds. They held on long enough for the climate to shift and opportunities to return. From those scattered embers, the fire of humanity blazed anew. This duality is the message the bottleneck carries into our time. It whispers caution: species can be erased and survival is never guaranteed. But it also sings with inspiration: fragility does not mean defeat. The very pressures that nearly destroyed us also shaped the strengths that define us: cooperation, adaptability, and intelligence. We are here not because the world was gentle, but because it was merciless, and we learned how to endure. That is the promise. That is the inheritance we carry forward. A reminder that weakness and strength are two sides of the same story, and that survival is never inevitable but always possible. In the next part, we'll turn to how this shared survival story acts as a mirror, reflecting the unity of all humanity and our capacity to endure whatever comes next. The bottleneck acts as a mirror, reflecting back the essence of who we are. When scientists uncovered this chapter of our history, they weren't just reconstructing the past, they were showing us why we think, act, and even feel the way we do today. Our most human traits were not random gifts. They were forged in the crucible of survival. The instinct to cooperate, even with strangers, is the echo of a time when every life in the band mattered. To hoard or fight would have doomed the group. To share and work together was the only path forward. That cooperative reflex is still with us, visible in everything from neighbours lending a hand to vast global collaborations. The same is true of our teaching instinct. Unlike other primates, humans spend years carefully guiding children, repeating lessons, telling stories. During the bottleneck, this wasn't luxury, it was necessity. If one elder died before passing on their knowledge, an entire lineage could lose the secret to finding water or making fire. The result is a species wired not just to learn, but to pass knowledge forward with urgency. Even our vulnerabilities trace back to those 117,000 years. Our susceptibility to disease, our relatively low genetic diversity, and the persistence of certain disorders are scars left by survival on the brink. They remind us that endurance always carries a cost, and that we are both resilient and fragile at the same time. When we look into this mirror, we see the balance of our story: a species scarred but strong, flawed yet enduring, bound together by a past that nearly erased us. The bottleneck explains not just where we came from, but why we behave as we do, a portrait of humanity shaped by desperation, perseverance, and hope. Next, we'll move toward the closing of this story, a reflection on how every one of us is a living testament to those few survivors who refused to give up. And now we return to the present, a world unrecognizable to those who came before. From a fragile thread of just 180 survivors, there now stand over 8 billion humans. Our cities blaze at night like constellations reborn on Earth, glowing so brightly they can be seen from orbit. We have reached across oceans and skies, stitched the world together, with the internet, sent machines to Mars and telescopes to the edge of the universe. We create symphonies and stories, paintings and poems, testaments of minds that once huddled in caves, clutching fire against the dark. Every bustling street, every crowded marketplace, every skyscraper brushing the clouds, all of it springs from a population that once could have fit inside a single school auditorium. That is the miracle. Humanity did not just survive, it flourished. It did not simply endure, it imagined, built, dreamed, and reached outward. But beneath every triumph, the truth of our origins whispers all of us are kin. Whether in New York or Nairobi, Sydney or Sao Paulo, each of us carries the same ancient scars and the same improbable inheritance. We are living proof that survival is possible, even when the odds are impossibly small. So the next time you stand in a crowded train station or walk through a city alive with light, pause for a moment. Every face around you, every language, every gesture, every dream is part of a single story. A story that began with a handful of people clinging to existence against a hostile Earth. Their persistence is our birthright. Their resilience is our legacy. From 1,280 to 8 billion, the message is clear: we are here because they did not give up. And so long as we remember that, neither will we. Lessons from the bottleneck. What 1,280 survivors can teach us about living today? 900,000 years ago, the human story almost ended before it began. Our ancestors dwindled to fewer than 1,300 breeding individuals. That's smaller than the population of a modern neighbourhood tinier than many high schools. For 117,000 years they clung to life enduring droughts, famine, and relentless climate change. And yet they endured. Every person alive today is a descendant of those few who refuse to give up. The discovery of this genetic bottleneck is more than a fascinating scientific fact, it is a mirror and a guide. Within it lie lessons for how to live meaningfully in the present. 1. Cooperation is survival. Those small groups could not afford conflict. A single quarrel could cost lives, weaken the band, and jeopardize survival. Instead, they learned to cooperate, to share and to carry one another through hardship. Today our communities, families, workplaces, and nations still depend on that same instinct. When we choose collaboration over division, we echo the very strategy that saved us. 2. Knowledge must be passed on. If an elder died without teaching where to find water or how to cook roots, an entire group might perish. This forged in us a deep instinct to teach and to tell stories. Our obsession with education, mentoring, and tradition stems from that ancient urgency. In modern life, it reminds us that what we know only matters if it can be shared and carried forward. 3. Adaptability is strength. The bottleneck survivors ate whatever they could, insects, tubers, eggs. They turned scarcity into invention. They learned to make fire their tool and to shift strategies with every changing climate. This adaptability became our greatest advantage. For us, it is a lesson that clinging to rigid ways can be fatal. Growth comes from flexibility and openness to change. 4. Resilience carries scars. We lost a bit of our genetic diversity in that ancient crucible. Some weaknesses we carry today, susceptibility to disease. Certain genetic disorders are echoes of that time. Survival often comes with costs. In our own lives too, resilience doesn't mean emerging unscathed. It means carrying scars and continuing anyway. 5. Unity is deeper than difference. Every human being descends from those 1-280 survivors. Beneath all of the visible differences of skin language and culture lies one shared inheritance. The bottleneck obliterates the myths of fundamental separation. We are one family cousins, many times removed, bound by survival, against impossible odds. Remembering this can temper prejudice, replace division with empathy, and remind us that we rise or fall together. 6. Hope is always possible. If our ancestors could survive 117,000 years on the edge of extinction, then there is hope in every crisis we face today. Climate change, political turmoil, personal struggles, none are greater than what has already been endured. Our history shows that humans are built not only to withstand hardship, but to transform it into strength. The bottleneck is not just a chapter of ancient prehistory. It is a timeless message we are fragile yet astonishingly resilient. We survive through cooperation, adaptability, and unity. And we thrive when we remember that we carry within us the legacy of those who refuse to give up. Thank you for sharing this quiet moment with me. Subscribe so the next stories can find their way to you as well.